Good morning. How are you doing? Are you enjoying it? Is it all fun? First of all, I would like to thank INCIBE for their kind invitation. And I hope you're enjoying it, but from the point of view of industry, we think these kind of events are paramount for sensitizing citizens. As we will see in the presentation, the human factor is one of the main entry points in an attempt to compromise a network. And so the task of INCIBE, amongst other organizations, is critical to help the industry protect our users. About myself, I'm Jaime Blasco, Chief Scientist of AlienVault. Do you know me? Do you know AlienVault? Sorry, do you know AlienVault? A few people. And as you might know, it was started here in Spain. In a few years, we had a chance to move to the US, and we've grown internationally. And we still have a large team of engineers based in Spain, but we've expanded internationally, and now we have our headquarters in Silicon Valley. I live in San Francisco for some years now, and I have this anecdote. How many in the room have you lived abroad for a couple of years? Hands up. Maybe this happened to you too. When I had a chance to move to the US, I was thinking, oh great, finally I will get better English. And I moved there, and it's true, it did get a bit better, but 2-3 years into it, I realized that my Spanish got worse. And 3-4 years later, what happens is that I don't speak Spanish or English. It's kind of a mixture of both languages. So if I say an English word or some Spanglish term, sorry about that, that's my main problem. How many of you work in the security industry? Hands up. So you might get this question over and over again. Your friends, your family. I get this. Oh, so much fun. You work on cybersecurity, hackers. What's your daily activity? Problem is, people have watched these films. We've been worse. War games was quite realistic. Then Sneakers is my favorite one. I think they are great at explaining what security is like and how it works. And it all got complicated. Hackers, 1995, they were skating everywhere. Then 2001, terrible because they mixed up hackers and sex. And we all know that's sci-fi. So it all got very complicated. So your family, people think that you've been to prisons, such as in Black Hat, and you help every government hack into nuclear plants. And that's the main problem. But if you're working on cybersecurity, you know, that's not like anything like it. For the last 10-12 years that I've been in the industry, I've just realized, and it's been just recently that I realized, because my favorite film is Too Fast, Too Furious, and that's perfect for the industry. I guess you all of a sudden find out there are thousands of companies offering security solutions. For each security control you want to set up, there's at least 20 companies that have a product that are just identical to each other and just the same. 1,400 vendors, 1,400 companies in the world. From the point of view of a user of a company, when you're going to buy a security product, no, yellow and white doesn't work very well, as you can see. But 1,400 vendors, how can a user know what the best product is and what's the product that will help them? What I wanted to discuss here was a bit of self-criticism. I'm used to giving those presentations where I explain how the security industry will help solve your problems and you will buy my product. Here, this time for self-criticism, and I guess it's time to discuss some of the problems that we are facing as an industry. First, that we sell you magic boxes. We sell you a product, and our sales reps, when they visit you, they promise a product will solve all your problems. You will plug your box to your data center, and no hacker will compromise your network. That's a lie, a blunt lie. And part of the blame falls with us, with the industry, because we are terrible at marketing. Next generation firewalls, next generation, next gen, it is just the same product, but we've just changed the name. So we've been selling firewalls for 20 years, and the one you get sold now is next generation firewall, but it's just the same one. Problem is the firewall concept. Networks have changed in the last 10 to 20 years. This setting up barrier after barrier doesn't work. Cloud technology, and most of your servers are not even on your network anymore. They are on Amazon's or Microsoft's. A firewall is not as useful as it used to be. These are the problem would be that out of 1,400 vendors, security vendors that I mentioned before, I can assure you that 80 to 90% just sell to the 1,400 top companies in the world. So the rest of the market does not have the right solutions to face threats. I cannot sell you the same product to you or Bank of America with 1,000 employees working on security. Same contrary to a startup or an SME where there is someone from Haiti that is also in charge of security. Both products will not work for all companies. We need many more vendors that do not only target large companies, but working on user protection and SMEs and the smallest companies. So it is estimated that for the next few years they will spend $1 billion, quintillion dollars, and going to Mars it costs you $500 million. So it costs you $500 million. So it's building it. It is training it. It is sending them to Mars. That all costs half the world expense on cybersecurity for the next 5 years. As a society, I think we are doing something wrong. I hope, because I work in the security world, but I hope that I would go out of work because everything was so secure and safe, and I could use my time on something more important, such as sending humans to Mars, and we could spend the same amount of money, actually half of it, of what they are going to spend on cybersecurity. The other problem would be that complexity is the enemy of security. These are very complicated networks where we have several segments. This is a firewall, and then I've read Gartner, and they say I need to buy 20 products that need to be installed and had to be integrated. Are we nuts? That level of complexity in the end means that we are not so safe anymore. And I can share thousands and millions of cases. Sony used to spend millions on cybersecurity. Target, for example, they took all the credit cards. I can assure you they were spending around $1 million in security, and had dozens of people checking out alerts and warnings, but they had so many security devices, so many warnings, that the complexity took the best of them, and hackers got all the information from those credit cards. Problem is not that they didn't have the technology to find out that there was a hacker inside it, but it was so complicated that they could not focus on the information that was important. So we need to learn from attackers. Most of them, they don't need complex techniques. They don't need them. They use very simple techniques that still work. I guess that as an industry, as a society, we need to redefine it from the beginning. We need to learn from them and go back to the basics. And what's the basics? Okay, so this is an example. Attackers use, for sure, and you all know what a macro is. It's a piece of code that you can embed into an Office file, and when you open it, it can get you infected with malware. And this is something that ransomware has been using of late. Do you think this is new? First proof of concept was back in 1995, then 1999, if you remember Melissa. This is one of the most best known viruses built on macro. And 2016 is still there. Lockheed, Heuristics, and lots of ransomware options use it. And it's been 21 years. And the attackers just use the same techniques. Even though we're going to spend $1 trillion in protecting networks. What about spear phishing or phishing? 2003, the Pentagon had an attack from China. 2009, Aurora compromised Google, Microsoft. Most of the larger companies in Silicon Valley. 2016, same technique. DNC, Yahoo. I could give you millions of companies that found themselves compromised by spear phishing or phishing. 13 years, just the same. What the hell? Do you follow the group on Twitter? If you don't, now go to your Twitter account and start following them. Often, what they say is true. This is one of the quotes I like the most. You can give a man a 0 day and he'll have access for a day. Teach a man to fish and he'll have access for life. And it's been seen. 21 years and they have the same phishing technique. And finally, denial of service. 1998, there was a famous hacker group, LAPS, in the US, visiting the Congress and explaining Congress people how they thought they could crash down the internet within 5 minutes. And this was the government. 2007, Estonia had a distributed service attack, which basically took down the whole country. And then 2016, you probably remember, a few weeks back, the problem with Mirai and the DNS attack that almost brings down the whole internet. The person who started this Mirai attack was a kid at home, was not even a state. It was a kid at home who thought of using this Mirai bot, which you probably remember was made up of IoT devices, mainly cameras connected to the internet and also recorders on the internet as well. And he almost managed to crash it all. Problem is, we still use on the internet the same protocols that were invented 30 years ago, that were not conceived from a security point of view. We still use DNS, we still use HTTP, sorry. And we have version number 2, version 6, DNS 3. We need to implement them. We cannot still use the same protocols as before, because a kid from home can destabilize it. All can destabilize the whole internet. We cannot go on like that. And if there are journalists in the room, please stop saying that our toasters can bring the internet down, because usually they are not connected to the internet, and the few that are in your own network. They were not part of the botnet for Mirai. What can we do? If I could start from scratch and throw away all the money I've spent on security devices, what I would do is think of the details. Focus on the details. Just change a few of those. One of the examples I wanted to share, and I would recommend you to look for this on the internet. This is Google Chrome security team's presentation. Here, there was no one. There was no security engineer working in the project. They were all graphic designers, and yet they managed the following. They narrowed down the amount of malware used by people with Google Chrome with something as simple as changing the messages that Google Chrome uses to warn you that you might be downloading a file with malware. Something as simple as saying, "We've warned you, do not download it." And say, "By the way, this might be malicious. By default, it will not be executed, but if you want, I can download it." And so, the click-through rate, out of 100 messages, there were 30 people who said, "I don't care. I would get infected." Just by changing the contents of the message, it went down to 4%. How much do you think this cost? It's just changing a message. And they reduce the rate of infection by a large amount. But let's blame the user. That's way easier. The user got an email, clicked, and got infected. So the attacker managed to steal their database, and it is the user's blame for sure. It's easier this way. Early this year, I had a chance to attend a conference by Rob Joyce, who is the TAO director. Have you heard? TAO is the hacking group at the NSA. They are the world cracks that NSA has underground and are the ones hacking networks in China, Russia, or North Korea. What he says is that the worst nightmare for NSA is someone who pays attention and uses basic techniques. I'm paying attention, I check blogs, I make sure there are no local users, I pay attention, and I check out all systems are up to date. It's not about spending billions into complex security systems. It's as simple as paying attention. Naturally, this is no silver bullet. Will not protect you from every attacker, will not protect you from the NSA, but it will protect you from many other attackers. But if you've ever spoken to a security vendor, fashion is that they have a new product that is in the cloud using AI, and that will spare you from all evil. But let's think it through before we say so. Unfortunately, I had a few slides where I would introduce you into artificial intelligence and machine learning, but I realized yesterday there was another colleague gave a presentation on machine learning. Were you here? Hands up. So I save a few basic elements, then I'll skip those. By the way, thank you, because you spared me 5-6 slides. Your work is amazing. Who could describe just 10 words to explain what machine learning is? Who's willing? No one? You said you were here yesterday, right? To summarize it, basically, if you were not at the presentation, the idea is, instead of defining new standards or rules, we would produce a example data set, examples transferred into a model, and then explain the result we expect. So you might have 1 million pictures of cats and dogs classified as cat or dog. You produce a model, you feed in all the training data, and the model in the end, through different techniques, will tell apart a cat from a dog with an error percentage that is quite small. What's changed? Because we've discussed neural networks for 10, 20, 30, 40 years now, I recall these papers where back in the 80s, the neural networks were already fashionable. If you pay attention to algorithms, the main algorithms, well, they haven't changed much. We've found new techniques to build new layers, to protect data in the right way. But then the main idea underlying a neural network is just the same. So what's changed? Basically, we have now access to many more data sets thanks to the internet, basically. Companies now have access to many more data, Google, Facebook especially. So picture the amount of data, and not just data, but classified information that they have control of. Google can have access to billions of pictures that have been classified into different classes, and they can use it to train large neural networks. Second was cloud computing. Not everyone can spend millions of euros or dollars keeping a data center with so many machines that have to be used for neural networks. And now you can go to Amazon or Microsoft and just train your neural network by using systems that only charge you per time of use. No need to invest into the whole hardware that you would use for days or weeks, but you don't need to own it. And then gamers, GPUs, so graphic units and boards rather, that gamers use. They found out that they would perform similar operations to machine learning algorithms, and with GPUs they can be speed up by 5 or 10 times. So the speed goes up 5 or 10 times. Main problems for deep learning and machine learning specifically have helped us, and have fully changed in recent years. Has been speech recognition, image and video recognition, machine recognition, and the natural language recognition or processing. Now we have bots on Facebook and other systems. You can talk to a bot and they understand what you're saying. Or Alexa as well for Amazon. Other bots such as Google that has already released one. So that you understand to what extent this has helped. ImageNet, do you know about it? ImageNet would be a contest, international contest or tournament that is held every year. You get 100,000 pictures. You can use as training 100,000 pictures that have been classified into 20-30 groups. 1,000 for a sheep, or 2,000 for a cat, 4,000 pictures of a car, and you need to build up an algorithm that, using set examples, can multiply by 20% to know your model mistake, or to what extent your model is good, or how good your model is. 2010, the error percentage rate was 30%. So it was not used. They were using features that were produced manually. Axis recognition, shape recognition, and this would be transferred into a quite basic model. Then 2012, someone came up with the idea of using neural networks. That was they went to the AlexNet, and it went down from 30 to 15%. That's error rate. And as you've seen, by using neural networks, even last year at the tournament, the error of the winning model was below a human's rate. So the mathematic method had lower error in the classification of images compared to a human. So this is the progression achieved within 4 years. It's been huge. Then we see that all large companies have come to realize that it is a good idea to share frameworks. And why is that? Because if you spend little money, well, it was difficult to build neural networks, especially because you had to program your own software. You had to have quite a math background. But then recently, other companies such as Google has published TensorFlow and others such as Tensor, etc. They've helped, but do not be mistaken. They do not release their frameworks because they want to contribute to society. The main reason why they do it is, well, I guess it's a pretty good description of what we are experiencing. This is 2001 to 2016, and you see the companies, the largest companies in the world from the point of view, financial point of view. 2001, only Microsoft was there as a software company that was one of the most important companies in the world. Then 2016, all 5 top companies, world companies, are software or hardware companies, which means these companies that are just the same, that publish the frameworks, are spending billions into machine learning and deep learning specifically. They've realized that to keep their place as a prevailing company, a leading company, you need to spend a lot or invest a lot into these resources. Then, second reason would be that not even intellectual property, algorithms are so important for deep learning. Not even the ideas they have. What matters most is that you need to have data. You need to have people, on the other hand, people who are experts. I read this article the other day, this paper, sorry. Google, Microsoft, Twitter, all together, for the last 2 years, they got the main professors that were teaching and lecturing in different US universities, MIT and Stanford. They're all working for private companies such as Google or Facebook. So this is a problem. The pioneers for deep learning, all those professors that hold a chair work in the private sector. And I guess this will be a problem because we will find some scarcity of people with the skills to understand the basis of deep learning. One of the solutions, when they realized this problem existed and built Open Artificial Intelligence, which is a non-profit organization trying to release as much as they can, so Google, Facebook do not have such a competitive edge ahead of others. And especially because, well, I don't agree with Elon Musk, but it is said that for at some point for the next 10 years, they will be able to create an artificial intelligence. And what is not wanted is to have just one single company controlling this. I think we're far away from that problem. This might ring a bell. From the point of view of cybersecurity, the main problems we come across are that we don't have enough people who are skilled to work in cybersecurity. This is one of the features or characteristics that we share with machine learning. As we've just seen, there are only a few people who are fully trained in machine learning and deep learning specifically. So what about those people who have training both in cybersecurity and machine learning? That would be a unicorn. Actually, if you have a chance when you go back home, just go and study machine learning because you already have these cybersecurity concepts clear. Because I promise you, if you've got both skill sets, you will not be missing your job in the next few years. This is great. We have neural networks that will solve all the problems in the world, and it all sounds nice and beautiful. But from the point of view of cybersecurity, when we follow this kind of algorithms, we need to be very careful. There is a series of challenges that we need to overcome before we move into production. The main problem from the point of view of cybersecurity is that we don't have so many data sets available to train this kind of algorithms. We don't have a data set saying this is all attacks and this is all non-attacks. It is very difficult to have access to that kind of information. Secondly, they don't have the proper balance, those incidents, from the point of view of data set. If you're classifying or comparing cat and dog, you can have 100,000 pictures of dogs, 100 pictures of cats. Problem is, for cybersecurity, you get an attack out of 100 million valid queries. So it is very unbalanced, and it tends to be a problem for algorithm training. You need to use much more time to make sure that there will not be false positives or false negatives. The false negative, false positive ratio you need for a security product needs to be very low. If not, as we said with Target, they had already a dashboard with 100,000 warnings, but they didn't know which ones were the significant ones because of false positives. The other problem would be what we said. This learning, this one-shot learning. When we are kids, we see that next time we see a dog, when we see a dog, the next time we see a dog, we know it's a dog. There's no need for us to watch 100,000 dogs to realize that the next one is a dog. Problem with current algorithms is they need more than an example to learn. And as we said, for cybersecurity, it's very difficult to have access to that amount of data. This is massive. The other problem is that for deep learning is that these are black boxes. You feed it an input and the output will be yes and no, or dog or cat, but everything going inside the model for deep learning is a black box. But you need to explain why the product made the decision, why it's like that. It is difficult by using deep learning to explain why the algorithm made a decision. If you use decision-making trees or other traditional algorithms, it will be easier, more simple, because you will explain why. And then adversarial examples. For some models, it's very difficult to cheat the model. I guess this will be quite self-explanatory. Can you tell apart a Labrador and fried chicken? Same with a Chihuahua or a muffin. From the point of view of a mathematic model, a muffin can look very much like a Chihuahua, and that's what it is. From the point of view of cybersecurity, a malware can look a lot like a Windows DLL, especially if the attacker does so on purpose. Problem with machine learning and deep learning specifically is the fact that there are some properties where if the attacker is smart enough and can reverse the features used by the model and build a similar model, can lead to and build adversarial examples to trick the model. So when designing it, you need to take it into account. And there are these very funny techniques where you would train a neural network to detect malware. You train the network to try and trick and cheat the other neural network. So to each other, they fight to each other, with each other, and the neural network learns to the extent where it can know whether it's been tricked or not. But for that, it takes lots of work and computing capability, and it is complicated.
Las ventajas y oportunidades que tenemos.
Advantages and opportunities that we have in terms of deep learning, machine learning and cybersecurity. Many of today's security products are based on rules and signatures. We know what is bad and that's it. If there is a new technique, either automatically or manually, someone has to tell the system that that technique is a bad technique, but that will not happen anymore with machine learning. In theory, a deep learning algorithm can generate its own conclusions, as we've seen before, based on a number of examples. So there will be other issues such as antivirus detection or anomaly detection, or what we refer to as user behavior analysis. User behavior analysis. How do you know whether an employee is uploading photographs to Google or whether he is exfiltrating a database, client database? Machine learning, I believe, can help out with that problem, because the examples as well as the user behavior will tell us to tell whether a person is exfiltrating data or is doing, or whether there is any anomaly there. Any of the products or things that can be improved a lot is smarter honeypots or deception. That is to say, a deception system, it's about traps that you put in your net. So therefore, if an attacker compromises your network, and then if they connect to your trap, is that because it is an attacker, because a user will not access to a server which is not accessible. So we are talking about an attacker scanning the system and finding that server. The same goes for files. You may upload a fake client database. You know that if someone accesses it, means that it is maluse and malware, because no one should be accessing that. Deep learning can improve those systems, make them smarter, and to customize them to the activity that is taking place in the network. Malware detection, of course. If you manage to train an algorithm, giving it lots of examples of malware and no malware, you will surely end up having a model which is highly predictive of malware. From the viewpoint of attackers, well, we have talked about this from the viewpoints of defense, for defensive viewpoint. What happens? The thing is that attackers can use these very same techniques, and actually they are doing it. Imagine that an attacker builds a model where the phishing emails that you get are customized for you, are specific, because the model has learned information, has learned things about you. Imagine that you are interested in photographs of a celebrity, or because you are interested in CyberCamp conference. So if that algorithm gathers details, information about you, and then it generates a customized phishing campaign for you, I can assure you that the percentage of people that will click, that will open that email, it is much, much higher than if you sent out a general and non-customized email. And second, vulnerability discover and fuzzing. So how many of you followed the in DEFCON the challenge? How many of you followed DARPA? Is government US government agency. Every year they define a problem which is difficult to resolve. In 2008 they launched a competition to build self-driving cars. What they do is to invite universities and companies to that competition that is held at that event. So the team that won in 2008 were the ones that 2 or 3 years later built Google self-drive car. This year they had a competition to create an FTF like the one that is being played here, but the difference is that those who were competing were not humans, but machines and models that people had programmed to play that CTF automatically. What will happen? DARPA is quite good at forecasting significant change in the industry. They gave lots of importance of self-driving car, and now we are seeing cars such as Tesla using that technology. If DARPA is saying that the use of machine learning and artificial intelligence in cybersecurity, we are at a point where there are self-autonomous systems that can play a CTF, find vulnerabilities and patch vulnerabilities automatically. So that's not reality. They created a mini version of an operating system. Obviously, they were not competing in the same conditions than a real attacker does. But still, people playing or taking part in the competition managed to resolve many of the problems. People are very happy to say antiviruses are dead because we have artificial intelligence and that will fix everything. No, we should not cheat ourselves. This is not the case. Not yet. And in terms of signatures, heuristics, and machine learning, AV companies are not stupid. It is not that new companies have arrived to use machine learning and to resolve or fix cybersecurity. Many antiviruses have been using machine learning for a long time to generate heuristics, and sometimes they use a combination of machine learning, heuristics, and signatures. And another reason is that the use of neuronal networks is not adequate because you need lots of performance. Imagine that you have to detect attacks in the net and analyze 100 gigas per second, and using a neural network is very complex because it will be high performance. It will consume lots of resources. So if you know which are the resources which are bad, use signatures and do not go into neural networks just because it is trendy. So this is what I want to say. First, focus on the problem, not on technology. There are many startups, and we see them every day on Silicon Valley. It's like, oh, we know a lot about machine learning, and we have created this startup, and we are going to resolve all the problems of the world. And then I ask, well, what is the problem that you resolve for the user? And say, oh, no, it's a neural network, and then we will focus on the problem. And I say, don't you think it should be the other way around? First, you find a problem, to detect the problem that users have, and then you choose the right technology to resolve that problem. Do not put technology first, put the problem first. And the last point that I want to refer to stunt hacking. We as an industry are doing it very badly in terms of marketing. So you know that every time there is a new vulnerability, we build a logo, we create a website. This is my favorite vulnerability. I found it on the internet. It's the first toilet with a vulnerability, with a CVE. Have you ever found that your Bluetooth key by default was 000 if someone is using the toilet? I don't know why the toilet has Bluetooth. Do not ask me that. I just don't know. Someone found a vulnerability, and what is most important, that lots of hype was given to it, and they said the attack vector was Bluetooth, and if someone is using the toilet, I can cause discomfort because I flushed the toilet, or I may open and close the toilet lid. And I said, my God. And this is what I wanted to explain. In last 2 years, it has become really trendy to discover a vulnerability, to build a logo for it, to publish it, and to say, well, all problems of the world are over, and there are vulnerabilities every single day. And this is just an example of the advertising that is made to some of vulnerabilities. Heartbleed. It was one of the first ones. It had a huge impact, lots of hype, and the same went for Shell Shock and for Ghost. Then, Bad Luck. A logo was created, a website, and then they said, well, the world will be over. Then in the end, it was man in the middle. You really need to have a highly sophisticated attack vector, not affecting very many organizations. The same goes for Poodle or for others, or Freak. When you see on the media that, read the small letter. Sometimes it seems that the world is about to be over, but actually it doesn't have the impact it looks that it has. So the same goes for malware. Malware campaigns, they have been very much present on the media. They have a real impact, such as claim media. For instance, Stuxnet had lots of impact because of the uranium enrichment facilities in Iran, but we have other things such as ransomware. Lots of hype given to ransomware, but the level of complexity and sophistication is null. The same goes for Mirai, the botnet that was about to bring down the internet the other day. This level of sophistication, well, it is non-existent. A kid at home did it somewhere. Actually, it was in the news yesterday. This is a campaign apparently coming from Iran, and then it attacked Saudi Arabia, and the thing that it did was deleting the hard disk. No other complexity. And the ones that are most important are the ones that show bottom right. That is to say, attackers or techniques that are very complex with high impact. However, they are not very much discussed. And you may notice that all those threats are intelligence services. That's their job. If I am an intelligence service, I'm going to use highly sophisticated techniques, and I'm going to make everything possible so that the media doesn't talk about it. So, for instance, if I'm a spy and if I am the media, I'm not doing a good job. So these ones are the most complicated, the most dangerous. So as I say, to finish off, I'd like to ask a favor from you. I know that many of you are students. You are the new generation. Those of you who you have the chance, the opportunity to start from scratch and to fix all the problems that we have. We as a society will be seeing the use of drones, robots, in genetic engineering. So very, very many advances here. We have to help protect all these systems, and we have to help so that they are designed with security in mind. And I ask you a favor, if I am to see you in 10 days, and I hope that machines have not stolen the work from you, your job from you, but the only thing that I just don't want to happen is that I just don't want to go back from the beach because my robot is asking me to update it. When you program robots, please bear security in mind right from the start in the design. Thank you very much for your attention.